history never ends. There was a famous book a few years ago called The End of History. I thought the most interesting thing about that book was why anyone ever took it seriously. I had to say I didn't read it. I got about one chapter in and decided I had better things to do. But history never ends, and that picture there is to remind you of that. That is me wearing one of my extensive wardrobe of interesting hats. But the point about it is that it is taken at the precise spot where the modern world began. And you might not know it, you might not know it even if you go there, but it's a small fishing village in the southwest of Portugal called Sagres. And this is where, in the 15th century, a junior prince of the Portuguese royal family set up the navigation school, which built the ships, new designs, that went down the west coast of Africa, went past the official end of the world, discovered Brazil. They were trading with Brazil 20 years before Columbus went to America, and the reason they didn't finance Columbus's expedition was that they knew you couldn't get to India that way because there was a continent in the way, and they'd been there and mapped it. The Portuguese kept excellent records but were very secretive. But now the main point in this story is that they went round the Cape of Good Hope and opened up the trade routes initially to Ceylon and India, and then to China and Japan. So the Portuguese expeditions of the 15th century are, I think, the beginning of the modern world, because they opened up globalized trade in things other than luxuries, silks and spices. So history never ends. There's a place where modern history began, and we're still living through it. One of the things we're living through is, of course, the machinations of the European Union, and I put that other title up there because there is a EU directive on design for the environment, and one of the things which I'm going to be saying here is that as so many European directives, unfortunately, has, I think, headed off in the wrong direction. So let me tell you what I think the right direction should be, and then final note before I really get into it. Like presumably you people, I've been very much attracted to industrial ecology, partly because it's essential, but also because it's intellectually interesting. And one of the reasons why industrial ecology is intellectually interesting is that it brings together people with a load of different disciplinary backgrounds. So, for example, I am by profession a chemical engineer. Tim Jackson is a physicist originally. I don't know that you would necessarily know that of either of us now, but I tend to look at things in the first instance as a chemical engineer might. So I'm actually going to apply some very simple chemical engineering thinking to the economy and see where it gets us. Let me acknowledge where I'm coming from. My intellectual mentor in this sort of approach is a man by the name of Walter Starhol. Just out of interest, has anyone ever read anything written by Walter? A few of you, good. The world splits into people who've never heard of Walter Starhol and people who think he ought to get a Nobel Prize. And I'm in the latter category. And a lot of stuff which I have seen published in high-profile articles in the literature over the last couple of years is actually what Walter has been saying for at least 35 years. And that particular book, The Performance Economy, is one which I very strongly recommend. I'm not necessarily recommending the second reference there, although I put it in as an illustration because this is appearing, I think it was published yesterday actually, in the trade magazine of the Institution of Chemical Engineers. The magazine is called The Chemical Engineer, and it's an attempt by myself and Julian Allwood, who's also probably well known to some of you. It's an attempt by Julian and myself to introduce industrial ecology thinking into the mainstream of chemical engineering. It's one of my arguments with the chemical engineering community. From time to time they say, I don't do chemical engineering anymore, to which I say, yes, I do. Chemical engineering is about managing material and energy flows, conventionally inside pipes. But if you extend that to include managing in material and energy flows through the economy, well, that's chemical engineering, but it's also industrial ecology. So that's what that article attempts to set out. So here am I, a chemical engineer, looking at the economy. and I will not put this in such overtly economic terms as perhaps Edgar did, but nevertheless, there is the way some parts of the economy function. So there's a stock of goods, material in use, that's S in the middle of the diagram. And I'm therefore looking at sectors where the stock of products in use is significant. It's a very simplistic analysis, but it does, I think, help to understand a few of the restructuring problems which we're going to face with this green economy. So I'm looking, for example, at manufactured goods. I'm looking at clothing, which represents a stock of goods in use. I may be looking at buildings and infrastructure, but that's a bit more complex. So let's take manufactured goods, mobile telephones, for example, and clothing as examples of the sort of system which I'm interested in. So there's a stock of material in use, and new goods go into use, that's the flow P, and used goods come out of use, that's the flow Q. But then you need to look at what happens to that flow Q and how much of it goes back into the flow P. So there's a chemical engineer's very naive view of the way some sectors of the economy work. And of course, if you do a material balance, which is the next thing you're bound to do if you're a chemical engineer, you say that the inflow is equal to the outflow plus the change of stock over time. Well, in the developed economies, Norway, even the UK sometimes, the stock of material in use is surprisingly constant over time. If you look at iron and steel in the British or Norwegian economies, that's actually remarkably flat over time. There are other materials, aluminium is one of them, where the material in stock is going up somewhat over time, but nevertheless, the changes over time are actually quite small compared to the annual flows. So a reasonable first approximation, actually, for a lot of sectors is to say that P and Q are equal. Okay, the inflow and the outflow are, over time, pretty much the same. Okay, now what happens to those flows P and Q, treating this as a problem in material flow accounting, if you like. Some of the material Q, which comes out of use, may be reused directly with minimal reprocessing. And the energy input there is what I've called E1 per unit of material reused. Even reuse doesn't come for free, so there's some energy input there. If you don't reuse it in essentially the same form, you might recycle it, and that requires some more energy input. E2, the energy per unit recycled, is usually larger than the energy required for reuse. But even so, E2 is, for most materials and products, smaller than E3, which is the energy per unit of material or per product needed for primary production. Perhaps the most obvious well-known case is aluminium, where the energy required for recycling is of the order of 5% of the energy required for primary production. Okay, now why does this matter? Well, Professor Herkwig referred to an energy crisis, and quite clearly we are not out of that. I personally think that the energy crisis of the early 1970s was actually wholly beneficial. And maybe we'll see what happens over the next few years. It might not be bad news. But there's another crisis which is looming. It was starting to emerge in the press. It was being hidden a bit by the rise in energy prices just recently. And this is the crisis of resource availability. And if you followed, for example, the things which have been happening in particularly China over the last couple of years, you will realize that there are a number of critical metals, and some non-metals, including phosphorus, actually, has been alluded to, but particularly refers to the critical metals, where the resource base is becoming stretched, resource prices are increasing, and the implications of that haven't necessarily been realized by everybody. Some of the companies I worked with whose business is dependent on a small number of critical metals have really only just woken up to this. So when I asked questions like, how much of these critical metals is in use in the economy at the moment in your stock, they didn't know. Now that's evidence to me of a company which has to rethink its management practices, because if you're dependent on a small number of critical metals, you better know where they are, and you better know when you're going to get them back when they come back from the stock in use. Okay, so we've got those two crises. We've got the increasing scarcity of certain key materials, we've got increasing energy prices, and however you look at it, that says to me that we need to reduce the energy consumption or the flows in order to maintain that stock of material in use. So if, remember, E1 is the energy requirement for reuse, that's the smallest of those terms. E2 is recycling, larger but still not as big as E3, which is the energy cost of making new materials. So that, I think, tells you where you ought to focus your attention. And this came out with a study I was asked to contribute to for one of the UK government departments recently, which asked us to look at the possibilities for reducing the energy consumption in industrial processes, and for me reinforced the conclusion that that is not the place to look. E1, E2 and E3 are already pretty low. They've been subject to economic pressures and there are thermodynamic limits on them anyway. So if you really want to reduce that energy consumption, the place to work is F1 and F2, the proportions of material which are respectively reused and recycled. That's where the big change promises to come in the green economy. So what are the options for reducing energy use or reducing throughput of scarce materials? Well, the first and most obvious one is to extend the service life. Because if the stock of material in use doesn't change hugely over time, then the best way to reduce the requirement of new material is to extend the lifetime of what's in use. That's the very simple point which Walter Stahl has been making for 35 years. And it bears repeating because it is so important. That's the place to start. It's probably the single most important transition to the green economy. Extend the lifetime of stock in use. Now for clothing, that's kind of obvious. And it's the opposite of what's been happening over the last few years. In the UK, and I don't know if this is true in Norway, but in the UK, the proportion of textiles in the municipal waste stream has gone up immensely over the last 3 or 4 years. And it's officially because it was called this by a House of Commons committee, it's officially called the Primark effect. And Primark is a chain of clothes shops which specialise in selling essentially throwaway clothing. So you buy a shirt at Primark and you expect to wear it maybe twice and then put it in the waste stream. And the evidence of that is, as I said, the increase in the textile content of the waste stream. So there's a pretty obvious place to start. If you want to reduce your demand on fibres and clothing, wear the stuff for longer, which probably means buying more expensive clothing in the first place. And if you look at the scope for changes in the economy there, it's a shift towards luxury clothing rather than Primark. And you can get rather more than the factor of two, by the way, Arnold, if you look at the figures. Now, the proportion of post-use product reused, that's the next one on the scale, if you want to reduce throughput of material and consumption of energy. For example, when I've finished with this suit, what happens to it? Well, I hope it will be reused. It goes off to a charity shop and someone else buys it. Post-use product recycled. Can the fibre be reconstituted into other fabrics? Well, can be. It was an industry which used to be known as shoddy. Unfortunately, the word shoddy came to mean second-rate, cheap. But shoddy was originally a fabric which was made by reconstituting fibres from used clothing. I'm sticking to the clothing sector, and so on. Okay, so rather than focusing on the energy or resource use in manufacturing processes, let's look at the proportion of stock in use which is recovered, reused and recycled. You could look at this on a more complicated basis. I'm not going to go through this one in detail because you probably won't be able to read it very clearly. I looked at it on a very simplistic way in that previous diagram, simply looking at stock, reuse and recovery and recycling. This comes from a paper by Allwood and others published recently in Resources Conservation and Recycling. And it simply points out that there are other loops within the economy, but if you want to achieve a better understanding of how to reduce energy consumption in the economy, then looking at the various routes by which products can enter and leave the economy, that's an important way to go. So what are the implications of this for the green economy? Well, for a start, if you take this really seriously, it means a major shift in economic activity. In effect, and this is another of the points that Walter Stahl has been making for a long time now, it involves replacing energy use by labour, mainly skilled labour. Okay, so by reusing and maybe recycling materials, we reduce the energy consumption, but it also means an increase in the labour component. Maybe that's a good thing. One of the things which is worth pointing out is that the increasing unemployment levels, particularly in, not just in Europe, in other industrialised countries, unemployment is particularly high amongst a particular age group, roughly from 18 to 30. So when I'm looking at the future of the green economy, the person I've got in mind actually is my 13-year-old grandson, because I need to ask what sort of world is he going to go into. And the re-engineering, the reusing economy strikes me as being quite an attractive way forward, because it means increasing the labour component of the economy, but it also means generating increased employment locally. If you're reusing goods within Norway or within the UK, that means demand for skilled labour in those economies. You're not going to, I hope, continue to export used mobile telephones and computers to Africa. You're going to try and mend them within the economy here. So that shift from energy to labour has potentially some big advantages. And of course, if the main factor becomes labour rather than energy, then some of the economies of scale get much smaller. So you can imagine smaller scale, more localised re-engineering and repair activities. It's actually going back to the sort of distribution of economic activity which characterised the early stages of the Industrial Revolution. History never ends, but sometimes it goes back. And I think the green economy has some of the characteristics of going back in time. And I interpret that as being entirely positive. How do we get there? Well, what sort of measures have governments got available to them to intervene? Well, the most obvious one is fiscal, taxes. At the moment, we're pretty bad at taxing labour and not taxing non-renewable resource use. As Professor Hettrich pointed out, energy is by and large subsidised, so don't do it. Tax the use of non-renewable resources, don't tax labour or renewable resources. How far can we go in that direction? Well, I'm not going to have time to go into it, but it does bear on the sort of arguments which Tim Jackson and others have articulated. And I think in particular, one of the key things that comes out from the debate over a so-called stationary economy is that you need to make a much clearer distinction between consumption and investment. And one of the things why I personally have doubts about the feasibility of a zero-growth economy is that if we are going into a period when we're going to need major restructuring, then that's going to need a lot of expenditure on genuine investment. I mean, one of the ways of interpreting the financial crisis was that what should have been, what was actually consumption was interpreted as investment. We need to be much clearer about that. Watch this space. Curiously, as far as I know, the place in the world which has gone furthest in the direction of what's called ecological tax reform, taxing non-renewable resources rather than labour, is, very surprisingly, British Columbia, which is an interesting experiment. It's a big enough economy. The population's slightly larger than the population of Norway. So it's a big enough case study to potentially give some useful results. I just hope the experiment is going to be allowed to run for long enough to see what happens and it doesn't get overthrown at the next election. So there you are. Then to remind you of some of the drivers that I've hinted at along the line, unemployment, particularly in specific age groups, and scarcity of certain key elements, which is definitely starting to affect industrial practices. So here are some final thoughts on what characterises the green economy, and these are deliberately taken directly from Walter Stahl. Don't repair something that isn't broken. Don't remanufacture something that you can just repair. And don't recycle a product if you can remanufacture it. Walter actually puts his money where his mouth is, and he has a car which is, I think, 30 years old now, with complete maintenance records. And it's very interesting to see how the cost of labour and the cost of non-renewable resources changes over the lifetime of the car. Reinforces the point I've been making here, the fundamental point, which is, I think the transition to a green economy means rethinking some industrial sectors and focusing not so much on energy efficiency, but on material efficiency, and in particular on extending the lifetime of products and materials in use in the economy. Thank you.